Hey, what's up? This is Madan sir here, and what right now, I'm going to help you with. This is called preparation of ketones. There will be three basic, method that has been already described in the NCRT, and I'll be concentrating on, those three because my motive is to make people or make student or make kids out there to understand things on their own effort and without going anywhere else. But they may need a little bit of help from my side. So that's the motive here. So this is what the topic is. Let me write that because I feel like, I talk too much. So this is what our topic is, preparation of ketone. And the first method I am describing you is from, from acyl chloride. Acyl chloride, which you also call it from acid chloride. But how this is, reaction is going to be, that's very interesting. And trust me, you're going to enjoy, or you're going to understand, you're going to enjoy, and you're going to get back again for your next topic. In order to prepare ketone from acyl chloride, the first reaction we have to do, we have to use a Grignard reagent. So this is a Grignard reagent, right? And when you react Grignard reagent with cadmium chloride, CdCl2, right? Let me write this in case you are new and you have no idea what this is. This is called Grignard reagent. Grignard reagent. In case you feel it's going to be a bit slow, I'm sorry for that, but the motive is to make you understand everything. And what this is cadmium chloride. Now, how the reaction proceeds, that's going to be interesting. You know what? You need to take 2 moles of Grignard reagent and 2 moles of cadmium chloride. Now probably you do know that the chlorine right here will form a negative charge and cadmium itself will form a positive charge. Right there magnesium halide will form a positive charge and this alkyl will form a negative charge in case the bonds are broken, right? So now what you have to do, you have to interact the negative one with the positive one, right? So what do you get? You get dialkyl cadmium. Dialkyl cadmium. Why I place this 2 right here? Because cadmium has a valency of 2. So probably you do understand how formula is made. This is not about 12th class, this is something from the junior. So dialkyl cadmium, another product is going to be MgXCl2. So this is going to be MgXCl2, right? So in the first step, we have to prepare this dialkyl cadmium. What this is called? This is called dialkyl cadmium. Right? Now, how this is going to be used? That's where we have to use acyl chloride. Now, what you need to do, you need to use acyl chloride. What an acyl chloride is? There you have your dialkyl cadmium and you need acyl chloride. You need acyl chloride. This is what acyl chloride is. So, so they make it like, R here. Okay, let's make it, methyl. Right? Now, think about the mechanism here. If this bond undergo cleavage, this will produce a negative charge, while this will entirely going to be a positive charge. Similarly, if the bond undergo cleavage, cadmium being a metal produce a positive charge and this will produce a negative charge. Now, what you have to do, you have to interact the positive with the negative one. So, what do you get here? You get CH3, C double bond O, and then you get, R2. Then you get R2. So this is what called? This is called a ketone here. You got your ketone out here. You got your ketone, right? And another byproduct is going to be cadmium chloride again. Cadmium chloride. So we have, this method completed right here. Now I'm going to take another one, right? So I hope you have understand, but in case you do not, let me repeat back. When Grignard reagent is treated with cadmium chloride, they undergo a kind of, displacement and it produces a dialkyl cadmium. When this dialkyl cadmium is treated with the actual reagent, acyl chloride, this, reaction mechanism clearly helps you how this ketone is formed. Yeah, but this too is not required here. Okay, so this is what, the first reaction looks like to be. Let's talk about the second one. Where our next topic is, which is the second one, from nitrile. Now, how nitrile can be used? When, let me write this statement also. When nitrile is treated with aryl magnesium halide, aryl magnesium halide. In case you do not know, this is also a Grignard reagent. This is also a Grignard reagent, followed by hydrolysis, followed by hydrolysis. It produces ketone. Right? Okay. Now I have given you the idea what I'm going to use. So what we have a nitrile here, and then we have aryl magnesium halide. So let's start with that. Nitrile looks like to be, RC, triple bond N. This is your nitrile, and then you have to treat it with, C6H5, which is actually a aryl group, also called benzene. C6H5 magnesium halide, right? We could also, write it like ArMgX, right? Now, try to get the reaction. So when a nitrile is treated with aryl magnesium halide, let me write the name. This is your nitrile, and this is your Grignard reagent. Right? So let's go back to the mechanism. When this bond undergo cleavage, it produces a positive ion here, and this produces a negative ion. If you want to know why this happened, magnesium is being metal. So this bond, definitely when cleaved, it produces a positive ion, while this will produce a negative ion. Now break the bond, break the bond right here. The question is, which bond you're going to break it? So the bond right here is, an important bond here. Right? So in this case, N will be a negative and this C will be a positive here. Now let's go with the interaction part. What will happen? I will place MgX right with the nitrogen and phenyl right with the carbon. So R, C, right? And let's place the C with the benzene group there, C6H5, right? And then you have a double bond with nitrogen, and it's coming out to be with MgX. Hope you understand, right? And then what last we have to do? We have to do reaction with water, right? And what this is called? This is called hydrolysis. So when you when you subject this particular reaction to hydrolysis, what happened actually? Just concentrate here. Magnesium halide has a charge overall positive, right? In case you want to know further more detail, magnesium has a +2, halogen has a -1. So overall this comes out to be +1. Nitrogen has a -3. So again, if you consider both, this is going to be a -2. So from water, oxygen will replace this entire group, right? So then what you get? You get R, right? C, double bond. So let's place that double bond right here, double bond. And like I said, NMgX will be replaced by oxygen, because oxygen state is also -2 here. So this is going to be -2, right? I replace NMgX, and then you have a benzene right here. So you got your ketone. This is your ketone, right? Last one is from benzene or benzene derivative. So this is your third one, from benzene or its derivatives. Right? So what it involves, let me write this statement. When benzene is treated with acid chloride, again it's acid chloride here, acid chloride, in presence of Lewis acid, in presence of Lewis acid like AlCl3, like AlCl3, it produces ketone. Right? Now, let me repeat back. We have our reactant benzene or benzene related, and then you have your acid chloride. So, we are going to use both of them, but in presence of the AlCl3. So, there you have your benzene, right? And then you have to use a acid chloride, and then this reaction is carried out in presence of AlCl3. If you want to know what is the role of AlCl3, actually this is a this is a electrophilic substitution reaction. So this actually initiates the reaction. In case you need more about the role of AlCl3, check out the 11th part organic chemistry in hydrocarbon, where there is an entire mechanism how electrophilic substitution reaction takes place and why it takes place. Right now I cannot go back there because that will mess up everything here. So this is, I would say, this initiates the reaction. So let's start here. We have hydrogen at all the places. Now when this bond undergo cleavage, then definitely this is going to be a negative and this will be a positive here. Similarly, when this bond will undergo cleavage, right, so this carbon is going to be negative and hydrogen is going to be a positive here. So what we need to do, we need to add the positive to the negative one and you will get your ketone. Sorry. So you have your C double bond O and then you have your R. So what this is your desired ketone, right? And in case you want to know what the byproduct is going to be, this is going to be HCl, because that H will react with the Cl. These are the three methods you have to use it in order to do any conversion while you have to prepare benzene to ketone, right? You can take any example here. You can change the R right here. R can be methyl, R can be ethyl, anything. There you can have any kind of benzene or its derivative. You have to follow the same mechanism. Right? In case you want to know, let me do one more example in very quick way. So this is your benzene, right? When you react it with CH3, CH2 and C double bond O Cl, right? I have to wipe this off. So this reaction will take place in presence of AlCl3. I'm taking anything on a random basis. So what we have to do, we have to cleavage this bond right here. So chlorine will be a negative and this entire will be a positive, especially this carbon will be a positive, right? And there since you have a benzene here, so let me draw the benzene also. So you have a benzene here. So the hydrogen will come out as a positive and the carbon will be a negative. So what do you get? You get benzene, right? And there you have, place this carbon right here. Double bond. Then there are 1, 2 more carbon. So CH2 and finally CH3. Right? So what this is called? This is called propiophenone, right? So with that, I must finish this video right here. I would say thanks for watching, thanks for your patience, and in case you have liked everything I did, I would say keep coming.